Selenium is one of the micronutrients which has been known by its toxicity, but around 1950s, that's when the science around selenium had changed because of its health importance, which were being recognized. One of the benefits of selenium is that it helps in the thyroid hormone metabolism, antioxidants defense system, as well as immune system. However, when we look at selenium, its deficiency is widely spread globally, but very little is known across the countries. We don't have so many evidence around many countries, especially in the sub-Saharan Africa. So this study basically was aimed now to quantify the risk of selenium deficiency at a national scale in Malawi. So there have been some studies that have been conducted based on the food dietary sheets. And what we noted is that the studies predicted that selenium deficiencies were at around 74%. This was based on the dietary selenium data. And then what we did basically around this study, we used the demographic health survey, which combined with the micronutrient survey. Demographic health survey had about 850 clusters across the country, but the micronutrient survey had about 105 clusters across the country. And each region had 35 clusters. So in each of those clusters, we collected blood samples and also urine samples. So this was covered across all the districts across the country. Where you're seeing the purple color, that's where the MNS was conducted, and the other color is where the DHS was conducted. So this is the data that represents the nationwide data. And in terms of the age groups, we collected data from school-age children, preschool children, pregnant women, women of non-reproductive age group, as well as men. And a total of about 3,000 samples, blood samples, were collected. This is just to demonstrate that during the study, we had to mount a laboratory at the community level, and then within the laboratory, we had to mount this for quality control and also to avoid contamination. This is just to demonstrate some of the challenges that we experienced. In some places, we had to use this, and then this is just to demonstrate what was happening in the laboratory. These samples were stored at minus 80 degrees. We used the mobile freezers. So in terms of the data analysis, we used inductive coupled plasma mass spectrometry, and the limit of detection for analysis was 0.001 nanogram per milliliter. And then we used the other statistical package for statistical analysis, and the linear model mix was used to quantify long and short-term spatial variation of selenium status. So what did we find? What we found basically was that selenium was widespread. The deficiency was quite widespread, except in these areas. It may not be clear where there's some lead. You see there's lead here, and also here, and across this. This side is the lake. That's where we found that at least the selenium, plasma selenium was better comparing with the rest of the areas. And on this side, you find this was the study that was also conducted based on the analysis of the grains. And this area, they found that there was substantial selenium in the grains, similar to this and this. This also confirmed with the plasma selenium that we got. It's the same locations that we found that plasma selenium was better comparing to the other areas. So we also found that there was greater variation between clusters than within the clusters itself, which shows that the selenium status was under strong geospatial control. There was a substantial spatial variation in deficiency risk, one due to soils as well as to proximity to the lake. And then selenium deficiency was also found to be prevalent in all social demographic groups. We have found that among the women of reproductive age group, those who were in urban areas were better off than comparing to those who were in rural areas, which was 34 against 62%. Then further to that, we had found that there was a high potential risk of selenium deficiency among children, which was estimated at 86%. But this has to be taken with caution because we used the adult thresholds. So using those thresholds, we found that the deficiency for children was at 86%. In terms of the thresholds, optimization of iodothyronine deodenase, what we found that almost 30% of women of reproductive age group had less than the threshold that is required for optimization of IDI. Similarly, with the glutathione peroxidase, 62% of women with reproductive age group had also less selenium blood plasma for activation of GPX. So this basically, we had to do this just to inform the policymakers in terms of decision that could be made around selenium, because this could provide a good picture for them to say, okay, this is the magnitude of the problem. In terms of where we had the green punches, this is where there was unlikely that they could be deficient in selenium. Unlike those areas where you see the red, these were the areas which were so certain that they were deficient in terms of selenium. While the gray areas, basically, it was more like, it wasn't so much certain around the selenium status. But in general, I think what we found that those selenium deficiency was quite widespread across the country, across all age groups and demographic groups. Thank you.